Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to continue naming alkanes with substituents. And so in the previous lecture video, I introduced to you the concept, the individual pieces, the individual steps that's at work. And so in this lecture video, we're going to take a look at more complicated organic structures, and we're going to see how to name them properly. All right, so let's go ahead and get started. So in this first example, we have this complicated looking organic structure that we are trying to name. And so I just want to remind you that every single end of this organic compound, everything that I've just kind of highlighted in pink, represents a carbon. And remember, a carbon must have 4 covalent bonds, either all single bonds or a combination of single, double, or triple bonds. And so for now, everything is single bonds. We're going to talk about double bonds, triple bonds a little bit later. But all of these highlights in pink that I've placed, they have 3 invisible hydrogens, right? And so that carbon that's highlighted in pink only has 1 covalent bond. And so therefore, there must be 3 invisible hydrogens that's present. That's just not drawn or shown. Okay. So let's go ahead and start by going through the rules. So the first step, I'm just going to push it out over here on the side. So remember that the first step is to identify the longest chain of carbons. And so, I don't know, I personally like to work from left to right. You guys can work from right to left. But you want to try out all the different combinations to see which chain of carbons is the longest. So I'm going to start here. That's 1, 2, 3, 4, 5, 6, 7. Okay. And so that's 7. So I'm going to take 2 steps back. So 6, 5. So I'm at 5 carbons. And then notice that there's a branching point going downwards, and it looks like there's some more carbons. And so I'm going to go ahead and put in 6 and then 7. So if I number it this way, I still have 7. So I'm going to go ahead and take 1 step back. So right now I have 6 highlights or 6 carbons. And then this is going to be 7 and 8. Okay. So it looks like if I follow this path that I've highlighted with the pink, I have 8 carbons that's in my organic compound, organic structure. And so I'm going to see if I can find, a different way to, a different path that could give me a higher value than 8. And so it looks like right now 8 is the highest value for the longest chain of carbons. So if I start from the right, 1, 2, 3, 4, 5, 6, there's no way that's going to beat 8, so that's not going to be it. And if I do 1, 2, 3, 4, 5, 5 is lower than 8, so that can't be it. 1, 2, 3, 4, 5, 6, 7. So almost there, but it doesn't beat 8. Okay. So you guys can try out other combinations, but the true answer for the longest chain of carbons is 8. Okay. So now that I've kind of highlighted my chain, my longest carbon chain, so I figured out that it's 8 carbons, I'm going to go ahead and name the parent chain. And since I have an 8 carbon chain, I'm going to use that prefix oct. Okay. And so since I have all single bonds in the parent chain, notice everything in the pink highlight is all single bonds. I'm going to use the ending ane. Okay, so my parent chain is named octane. All right, so the next step is to number the longest chain. So number the carbons so that the lowest value is going to be on the substituent. So you want substituent with the lowest carbon number. Okay. And so I'm going to go ahead and zoom in here. And I'm just going to go from left to right. So if I go from left to right, what would the number system look like versus right to left? So 1, 2, and notice that I'm following my pink dots, right? You want to follow the pink dots because everything that's not a pink dot, or everything that does not have a pink dot is going to be a substituent. And so 1, 2, 3, 4, 5, 6, 7, and 8, okay? So this is going to be my number system if I go from left to right. Now if I go from right to left, now I'll do this in a different color. Let's just do this in green. I have 1, 2, 3, 4, 5, 6, 7, okay? And then 8. All right, so now that I've numbered my carbons left to right, right to left, I'm going to see which path will give me the lowest value for my substituent. And so I am going to look at, I'm going to compare a couple points here. So here, my substituent is found on 2 and 7. I have no substituent on the next 2 carbons, and then there's a branching point. And it looks like I have a substituent on 3 and 6. Okay. And I have a substituent on 4 and 5, 5 and 4. Okay. And so just to maybe clarify it before I start circling these things, you guys might be asking yourself, well, how do I know what my substituent is? Remember, everything that's not in pink, everything that's not highlighted in pink is going to be our substituent. So this is our substituent, this is a substituent, these 2 carbons are our substituents as well as this. Okay. And so when I was circling the stuff in red, I'm circling the carbon that has the green substituent, that has the substituent which is in green highlight. Okay. All right. And so I want you guys to notice that the substituents themselves, the ones that are in green, are not the same. Here I have 3 methyl groups and an ethyl group. And so whenever you guys get these different substituents, you guys can figure out which one is the correct path by adding up the numbers, right? And so, for example, if I add up everything in blue, so if I go from left to right, okay, so everything I'm writing right now in blue is representing left to right, so I'm looking at the blue numbers. And so I have a value at 2, 5, and 6. So if I take 2 plus 5 plus 6, okay, that's going to give me 11 plus 2 is 13. Okay. So if I go from left to right, the total value of where those carbon numbers, so these are the carbon numbers that have a substituent, the total value is 13. Now I'm going to go ahead and change to green, which is representing my number system from right to left. Okay. Right to left. And so notice that here I have 3, 4, and 7. Okay. So 3 plus 4 plus 7. So here in this case, I will get 10, and then add that with 4, that's 14. Okay. So it looks like if I number my carbons from right to left, I get a higher value for my substituent. And therefore, the number system, I want to number my carbons not right to left. I'm going to go ahead and number it left to right. Okay. So this is smaller. And you're always aiming for the smaller value. And so as I'm erasing some of this stuff, some of you guys might be thinking, wow, this is just so nitpicky. And so the reason why we have to be nitpicky with naming these organic compounds is that if everybody wants to like number their carbons on their own system, there's no consensus, right? And so we want to be precise with the numbering. So that way, when you tell the reader this is 2,2,3-diethyl or whatever, they can literally draw it out and understand what you're saying. And so it's important for us to follow these rules, especially for organic chemistry. All right, so now that we have the correct number system, we've figured out that the path going from left to right will provide us the least value. The next step is to identify your substituents. And then we're going to go ahead and add the carbon number to them. And so it looks like this guy in green, notice that there is just one singular endpoint, if you will. And so this little guy right here, that's representing CH3. And a CH3 is known as methyl as a substituent. Okay. And notice that this methyl is attached to carbon number 2. Okay. And so we're going to go ahead and complete this picture by saying 2-methyl. So the 2 represents that it's on carbon number 2. Okay, which is right here. So hopefully you guys got that. Now, if you guys look at the bottom, once again, notice that there's just that one singular endpoint. And so that singular endpoint is the organic abbreviation for another methyl group. And if you look at where that methyl group is found, it's also on carbon 2. And so then we're going to go ahead and describe this substituent as 2-methyl. Now, if you guys recall, you guys are going to separate numbers by using the dash, and then you guys are going to separate numbers and letters using the dash. So it's 2-methyl. All right. So if I look down, notice that I'll see another singular endpoint right here. So this is another methyl. Okay, so that's another CH3. And if you look at the position of where that methyl is found, it's found on carbon 6. And so you're going to say 6-methyl to describe that point. And if you guys are looking at carbon number 5, notice that we don't have a singular endpoint. This is like a corner. So that represents one carbon. And if you kind of think about how many hydrogens there are on this carbon, there are supposed to be two, right? So this is 1, 2 covalent bonds. And so that carbon needs two more, and that's going to come from the hydrogens. So that's CH2. And then once again here at this endpoint, since it's an endpoint, it's going to be a CH3. And so you have CH2 bonded to CH3. If you guys have this specific structure, that's an ethyl. Right, so 2 carbon. Remember, eth is 2 carbons. And so since it's on carbon 5, we're going to say 5-ethyl. Okay. All right, so now that we've identified our substituents, what we're going to do is put the pieces together, right? And so the next step is name the compound or molecule. And we want to put the substituents. So name the substituents first. And you're going to do it through alphabetical order. And this alphabetical order is representing its actual name, not the prefix. And then I'm just going to go ahead and add this in here and make sure to combine repeating substituents. Okay. And I'll go over the details. These are just some key points for you to remember. And then last but not least, you're going to name your parent chain last. All right. So let's go ahead and combine all of these names. So I have a 2-methyl, and I have another 2-methyl, and I have a 6-methyl, and I have a 5-ethyl. So we're going to name the substituents first, and we need to do it by alphabetical order. So which substituent do you think we're going to name first? The methyl or the ethyl? Don't pay attention. Excuse me. Do not pay attention to the numbers because we're only doing it by alphabetical order. So let me see here. E, M, M, or M. Okay. And so if you said ethyl, then you're absolutely correct. And so we're going to go ahead and put down 5-ethyl. Okay. All right, and so if you guys look at the remaining substituents, we have repeating methyl groups. We have a methyl group on the second position, we have another methyl group on the second position, and we have another methyl group on the 6th carbon position. And so we're going to combine all of those methyls in one name. And we're going to make sure that the numbers are represented correctly. Okay. And so to do this, we're going to combine them as 2. Okay. So we have the 2-methyl right here. And then we have another 2-methyl, so we're going to say 2. Then when you separate out numbers, you put a comma 2. And then here, since 6 comes after 2, then we're going to go ahead and describe the 6 for that same methyl group. And we're going to separate it by using another comma. And since now we're going from a number to a letter, we're going to put dash. So real quick, sorry. We have 1, 2, 3 methyl groups. So since we have 3 methyl groups, we're going to say trimethyl. Okay. And so now that I've named all of my substituents, 2,2,6-trimethyl, and my 5-ethyl at the very beginning, the last thing that I need to do is just name the parent chain. And so the name of the parent chain is going to be octane. First thing that we did. All right, so this is going to serve as like the backbone for the way that we're going to order the arrangement of the name of this organic compound. Now we want to clean it up. We want to make sure that we are putting in the right dashes, commas, or no spaces and stuff. And so notice that we're going from a letter to a number. And so letter to a number, we need a dash. And so I'm going to go ahead and move this piece closer. Okay. Now, if you look, I'm going from a letter to a letter. If I'm going from letter to a letter, you don't put any dash or commas. You simply combine it as if it was one word. And there you go. This is the name of this organic compound, 5-ethyl 2,2,6-trimethyl octane. Now, once again, I kind of mentioned this in the previous video, but I really do encourage you to draw what you guys named. And it's really important for you guys to draw what you guys named so that you can see, so that you guys can get some practice on converting the name to its organic structure. And it doesn't have to look like the original structure to begin with, just because you might have done it from left to right or right to left, but it should be a reflection of it. So let's go ahead and do this. So the first thing that I'm going to do if I want to translate the name to a skeletal structure, I'm going to focus on my parent chain that's telling me octane. So I'm going to put in 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's done. Now, when you're drawing your own structure from the name, you can order the numbering of the carbons from left to right or right to left. It doesn't matter. The reason why is because you're creating your own carbon number system from the name itself. And that technically wouldn't be right or wrong because you're not going from the structure to the name, right? You're going from the name to the structure, so you're building your own compound. So I'll just be consistent. I'm going to go from left to right. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now, this is telling me that on the 5th carbon, I have an ethyl group. So here's my 5th carbon, and for me to draw an ethyl group, I need to draw 1, 2 carbons. Oops, 1, 2 carbons. And that's my ethyl. And notice here I have 2. On the 2nd position, I have a methyl. So I'm going to draw a line going up. That's my methyl. On another, on the same position, I have another methyl group. Okay. And then on the 6th carbon, I have another methyl group. Okay. And so this is the organic compound that I get. And so if I zoom out, notice that the organic structure is a little bit different than what you guys see, and that's okay. And the reason why is because there's a rotation. There was a rotation along the fourth and the fifth. So if you guys rotated the fourth and the fifth carbon about 180 degrees, so basically you're flipping that position, you get the exact same structure as the original. And once again, remember, these organic compounds, especially these alkanes, the single bonds can be rotated 360 degrees as long as there's no like bulky substituent or steric strain. In addition, remember that these organic compounds are three-dimensional, so you guys can rotate them any and every which way. Okay. So hopefully you guys understood this method of naming, like the logical steps and trying to get the name from the structure. And then from the name to the structure back again. All right, let's go ahead and look at another example. I'm not going to write the steps down. You guys can kind of like review on. You guys can rewind the video, pause it, take a snapshot, take notes, what have you. I'm just going to go ahead and start verbally giving you the instructions. All right, so I'm going to go ahead and make sure that I'm going to be using pink to highlight the parent chain. So I need to figure out my longest chain. 1, 2, 3, 4, 5, 6. Okay. Take one back. There's a branching point, and so that's also 6. Okay, so it doesn't matter if I go left or right, I have 6 carbons. Okay. And so let me take a step back. I have another branching point here on the third. So 1, 2, 3, 4, 5. Okay. So right now my highest is 6, so that's probably not the right answer. So I'm going to go ahead and take a step back. And I have another branching point over here on the fourth carbon. I'm going to continue. So 5 and 6. So it looks like 6 is still the number to go. Okay. And then there's one more path that I haven't tried. 1, 2, 3, 4, 5, 6. I don't know if you guys saw that. So just be very careful, right? So you start from one end and start identifying different paths to determine the longest carbon chain. Okay. So far, my highest value is a 6. Here's another endpoint. So 1, 2, 3, 4, 5. Okay. So 5 is less than 6, so that can't be it. 1, 2, 3, 4, 5. Same thing, can't be it. And so it looks like it doesn't matter which way I go. The longest carbon chain is 6. And so I'll be a rebel here. I'll just do this. 1, 2, 3, 4, 5, 6. Okay. And so if you guys number it in this way or in this perspective, you guys should still be able to get the correct organic compound, organic structure. Now, if you guys don't want to do it that way, that's fine. We can go from left to right just so it's consistent. 1, 2, 3, 4, 5, 6. Excuse me. Okay. All right. So let's go ahead and number this. Now that we've found the longest chain, which is 6, we're going to go ahead and number it. I'll go ahead and use blue. So blue is for left to right. So I have 1, 2, 3, 4, 5, and 6. I'm going to use green to go from right to left. 1, 2, 3, 4, 5, and 6. So I'm going to highlight my substituents. So these 3 are a substituent. Actually, this whole item right here is a substituent. Okay. this whole item right here is a substituent. And so it looks like the number that I'm going to compare are these two. Okay. And so if you guys look at what I've circled, we have 3 and 4 and 4 and 3. Okay. Now if you do the math, I'll just be consistent. So I'm going to go from left to right. So if you look at the numbers in blue, I have 3 and 4. So 3 plus 4 is equal to 7. If you look at the numbers in green, if you look at the carbon numbers, 3 and 4, that has a substituent on it. If I go from right to left, this is going to be 3 plus 4. That's equals to 7. And so here it looks like they're both 7. And so one might say, okay, well, since they're both 7, then I guess we can do either path, right? Okay. And so let's go ahead and name this. So let's name these two substituents. Let's go ahead and do the bottom one first. So notice that we have 1 and 2 carbons. So 2 carbons is eth. Since this is a substituent, this is ethyl. Okay. Maybe I need to do this in a different color, just so the numbering's not confused. I'm running out of colors. And so 2 carbons, so that's eth, or ethyl. Here I have 1, 2, 3 carbons on this substituent, so I know that this is prop. Or propyl. But if you guys look, there's kind of like symmetry, right? And so remember, if there's symmetry in your substituent, you put an iso. So this is isopropyl. Okay. And there's a reason why I wanted to name my substituent first. So when you guys come across a situation like this, where if you number from left to right or right to left, and when the sum of it is the same, then you have to choose the path that would give the lowest carbon number to the first substituent that you guys are supposed to name in order, in alphabetical order. And so notice that the name for isopropyl, it starts with the letter I. And the letter that starts with, the first letter of ethyl is E. And so E comes first before I. And so therefore, you want the number of ethyl to be the lowest. And so because you want the number of ethyl to be lowest, because it comes first, when you're naming the substituent, then the path that you guys are going to choose is going to go from left to right. Okay, so if you guys look at the path going from left to right, carbon 3 would describe ethyl. If you go from right to left, carbon 4 would describe ethyl. And so you want the lowest carbon number to describe your first substituent. And our first substituent that we are going to describe is ethyl, because E comes before I. Okay, so lots of things going on here. And so we're going to go ahead and cross this out. And we determined that even though these values are the same, you're going to choose the number system that gives the lowest carbon number to the first substituent to be named. Okay. All right, so we're looking at this new scenario where, you know, the sum of the numbers of the numbering system gives us like the same value. So what do we do then, right? If they're the same value, and this is what you do. Okay. So I'm going to go ahead and start erasing the path, the number system that doesn't belong. It also kind of frees up all the scribbles. All right, so here in this case, it looks like it looks like ethyl is on carbon 3. And so we're going to say 3-ethyl. And it looks like isopropyl is on carbon 4. So this is going to be 4 isopropyl. Okay. All right, so now that we've named all of our substituents, 3-ethyl and 4-isopropyl, let's go ahead and put everything together. And by the way, since your carbon chain is, the maximum number is 6, we know that this is hexane. Okay. So putting these pieces together, I'm going to name my ethyl first. Then I'm going to name my isopropyl, my 4-isopropyl second, because that's my second substituent. Then now that I have all of my substituents named, the last thing I'm going to name is my parent chain. All right, so then to name this, we have 3-ethyl. Now, notice that we're going to, oh, well, I'll just list it down. So 4-isopropyl. Okay. And finally, we have hexane. Okay. All right, so let's clean up what I've summarized. I'm going from a letter to a number. So letter to a number means that I need a dash between them. So I'm going to go ahead and move this piece a little bit closer. Now, here I have a letter to a letter. So that means that I don't need any dashes or commas. I just need to insert this so that they are very close to each other. There's no space. Okay. And this is our answer. 3-ethyl, 4-isopropyl hexane. Now, if you want, you can go ahead and draw what you guys named, just so you guys can get practice in translating this name to an actual skeletal structure. And so here we have 3-ethyl, 4-isopropyl hexane. Hexane is my parent. And so I have 1, 2, 3, 4, 5, 6. And, you know, just for the sake of it, I'll go ahead and number it backwards this time. 1, 2, 3, 4, 5, 6. Remember, I can number it. When you're going from a name to the skeletal structure, you guys can number it any which way, left to right, right to left, because it doesn't specify in the name, right? There's no indication in this actual name on which way you guys should number your carbons. And so I know that on the third position I have an ethyl, so I'm just going to go ahead and add 2 carbons. And on the fourth position I have an isopropyl. So I need 3 carbons and they need to be symmetrical. Okay. So this would be my skeletal structure for this specific for this name of this organic compound. And if you guys are going to compare that to the original structure, you'll notice that it's just a mirror reflection. So notice that the isopropyl is up, and here the isopropyl is down. So there was like a flip, and then there's like another rotation. So basically, you guys can go ahead and practice that as much as you guys can, so that you guys are familiar with going from the name to the skeletal structure and vice versa. All right, so let's go ahead and move on to another problem. Actually, before I do, real quick, I want to go ahead and redo this problem, and I'll start it from the skeletal structure that I just drew. I don't know if you guys recall from earlier, I was able to like number this way, right? So 1, 2, 3, 4, 5, 6. Now, if you guys numbered your carbons this way, the name of the compound would actually be different than what you guys have at this moment in time. And so I'm going to do this like very quickly. Should I erase what I have here? No. Okay. And so if what I highlighted was the parent chain, there's still like 1, 2, 3, 4, 5, 6. So there's still 6 carbons, so I know that this is hexane. If you guys look at the substituents, notice that there's no more isopropyl. And so I have like an ethyl and I have a methyl group. And if you guys named it in this in this specific perspective, the answer would still be correct, right? So the main point is that there might be two or more different correct ways to name a compound, depending on what you consider as the parent chain. And so, you guys don't have to worry too much as long as you guys are consistent with the actual way of naming that compound. You guys should be good. And I'll obviously consider the different answers there could possibly be. And so here, let's see. If I were to number it in this path, the correct way of numbering this organic compound is going to be 1 at the bottom, 2, then 3, then 4, then 5, then 6. The reason why is because I want my substituent to have the lowest value. And you guys can do the whole sum game, but I'm just going to kind of speed things along. So here in this case, it's going to be 3, 4 diethyl, 2 methyl, and then that's it for my substituent. So I'm going to go ahead and tack on the end, which is hexane. So if you guys name the organic compound as 3,4-diethyl 2-methylhexane, that's also a possible correct answer. And if you guys named it as 3-ethyl 4-isopropyl-hexane, that's still giving me the same compound. And that's basically what happens when you have like branch substituents. There could be more than one answer. But sometimes for organic compounds, there could only be one way of naming. Okay, so I just wanted to bring that, I just want to shed some light on that, just in case you, in the video thought that, oh, maybe, if I want to number it this way, what would the answer be? Okay. All right, so let's go ahead and look at a different compound. We just have a couple more to go, I believe. So once again, I'm going to use pink to determine the longest chain in my organic compound. So here I have 1, 2, 3, 4, 5. Okay. So that's one way. So 5 right now is my highest. So if I do 1, 2, 3, that's not it. So 1, 2, 3, 4, that's not it. 3, 4, that's not it. And 1, 2, 3, 4, 5. Okay. So it looks like 5 is the highest value. So I know my parent name is going to be pentane. Okay. And once again, just go ahead and choose one consecutive chain of carbons and then name it as is. So if I do this, 1, 2, 3, 4, 5, that would make this, and this a substituent. Okay, so everything in green is going to be a substituent. Everything in pink is going to be my parent chain. So I'm going to start numbering. 1, 2, 3, 4, 5. So if I go from left to right, notice that I have 1, 2 substituents on carbon 2. So I'm going to put 2 plus 2. And then I have another substituent, actually 2 more substituent on carbon 3. So 3 plus 3. Okay. And so that's going to give me 10. And now if I do this in green, so right to left, so I have 1, 2, 3, 4, 5. Okay. If you guys look at, let me just erase this. Erase this. Oh. Okay. All right. So if I look at, oh no, what happened? If I look at this, I have 2 substituents on carbon 3, so I'm going to put 3 plus 3. And if I look at this, I have 2 substituents on carbon 4, so I put 4 plus 4. Okay. So already you can probably see that the right to left numbering system for this specific example is going to produce a higher number. And so if you add all that up, that's going to give us 14. And so it looks like if I number from right to left, that's going to give me a higher value. And so numbering from left to right is probably the most preferred path. So I'm going to go ahead and erase some stuff here. Okay. And I'm just going to go ahead and keep the left to right numbering system for my carbon chain. All right, so looking at this piece and this piece, notice that they're both methyl groups, they're both CH3s, and so I have two, well, so I have a 2-methyl here, and then I have a 2-methyl here. Okay. So here I have another end, and there's only 1 carbon, and so that's going to be another methyl group. So this is going to be 3-methyl. And same thing here, I only have one point, so that's going to be 3-methyl. And I'm putting 3-methyl because, or 3-methyl, because those substituents are on carbon 3, while both of the substituents here are on carbon 2. And so if I were to put the pieces together, notice that the only substituent that I have are methyl groups. And since I have the same substituent, I need to describe that correctly, right? I need to put them together since they're the same. And so I'm going to say 2, 2, 3, 3. So notice how I'm adding commas for each number. So each number is supposed to represent one substituent. So I have 4 substituents, so there should be 4 numbers. So 2, 2, 3, 3. And then since I have all methyl, I have 4 of them. And so I need to put a dash because now I'm converting from number to letter. And that is going to be tetramethyl. Okay. And then finally, my parent name, now that I've named all of my substituent, is going to be pentane. Okay. So that would be the answer to this problem. So I'm hoping that you guys are getting the hang of it by going through this exercise. I know that some of these, the naming and the numbering is a little bit, tedious and maybe a little bit specific and maybe overwhelming. I'm not too sure how you guys are feeling about it. But once you guys get the hang of the numbering system and identifying the substituents, the parent chain, all of this is actually kind of fun. It's like a puzzle, right? And so it's for those who like Sudoku and all of that stuff, then numbering these and naming these organic compounds might be like this nice, therapeutic, enjoyable session. Okay, so let's go ahead and go through this compound. All right, so same scenario. First step, find my longest chain because that's my parent chain, and that's going to be highlighted in pink. So I'm going to start from left to right. 1, 2, 3. And then notice I have a branching point here, so I'm going to put 4. So 4 looks still pretty small, right? So 4, 1, 2, 3, 4, 5. So 5 right now is the highest. Okay. 1, 2, 3, 4, 5. And then I have another branching point, so let me go up. 6, 7. So it looks like 7 is the highest so far. Let me take a couple steps back. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is larger than 7, so we have 9 consecutive carbons. Now if I take a couple steps back, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go down, it'll still give me 9. Okay. So it doesn't matter which carbon you use for 9 in this scenario because they're both equivalent. I'm just going to go from left to right. All right, so now that I've numbered now that I've identified my carbon chain, 9 carbon chain, that's nonane. Okay, so that's my parent. And so now that I've named my parent chain, which is a 9 carbon chain and it's nonane, I'm going to go ahead and create my numbering system such that the lowest carbon number, such that the first substituent is going to have the lowest carbon number. So left to right, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. And so let's go ahead and add up some stuff. So here, notice I have 2 substituents on 3. So if I go from left to right, I have 3 and 3. So 3 plus 3. Okay. And then I have a substituent on 5. I only have 1 substituent. And let me just highlight my substituents here. So I have this and this is my substituent. So notice that there's 2 on 3, there's 1 on 5, and 1 on 8. And so 3 plus 5 plus 8. Okay. And so here, this is 13, 16, and 19. All right, so now that I have confirmed the total number, I'm going to go ahead and change my numbering system. So here I have 1, 2, 3, 4, 5, 6, and 7. Okay. All right, and let's see here. So I have right to left. Okay, so I have 1 on 2. I have 1 on 4. And then I have 2 substituents on 5. Okay, so let's tally it up. This is 10, 14, 16. And it looks like we have a winner. This time, the numbering system going from right to left will provide us the least value. So therefore, in this scenario, the numbering system is going to go from right to left. Okay. All right, so now that we've created our numbering system, let's go ahead and start putting these pieces together. So this is a methyl group, and it's on carbon 2. So on carbon 2, I have a methyl group. That's 2-methyl. And then on the 4th carbon, using this number system, wait, I feel like I didn't do this one correct. Sorry, I think I skipped a couple stuff. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, whoops. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I apologize. So we need to do a recount. So I have 1 on 2, and then I have 1 on 5, not 4. And then I have 2 on 7. Okay. So here 7 plus 7 is 14. 2 plus 5 is going to be another 7. And so 7 plus 14, that's going to give me 21. Okay. And so here in this case, it looks like the green path kind of lost. And so I'm going to go ahead and just erase this. Okay. And so I'm going to go ahead and keep the left to right. So here I have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. All right, so let's go ahead and look at some stuff. So here, it looks like I have a 3-methyl. Here I have a 3-ethyl. Here I have a 5-ethyl. Then here I have an 8-methyl. All right. And so since these are our descriptions for the substituents as well as their number, we're going to go ahead and start combining them. So notice here we have a methyl and a methyl, and here we have an ethyl and an ethyl. And so we have to figure out which of these two comes first, the methyl or the ethyl. And to do that, we want to look at the first letter of their name. So we have E's and we have M's. And so E comes before M, so ethyl must come first. And between the two ethyls, the first ethyl that comes first is the 3, right? So 3 is lower than 5. And so we're going to go ahead and write 3, 5 dash ethyl. Oh, sorry, not ethyl. Diethyl, because now there are 2. So diethyl. And the capitalization, there's no specific rule for it. And so if you guys want to lowercase everything, that's fine. If you want to uppercase the first letter, that's fine as well. And so I'm going to put 3, 5 dash diethyl. Remember, the comma is supposed to separate out the numbers. If you don't put a comma, then that's 35, right? And so now that I'm done with my diethyl, I'm going to describe my methyls. And so here in this case, it's going to be 3, 8 dash dimethyl. And once again, when you guys are ordering this, make sure it's the first letter of the actual name, not the prefix, not the dis, not the tris, not the tetras. And so since my so I've basically finished numbering or incorporating these two, and so now I just need my parent name, which is nonane. Okay. All right. So to clean this up, we need to think about how we're going to join these guys together. Okay. And so here we have a letter to a number, so I need a dash. And here I have a letter to another letter, no dash, no comma. Just take this guy and write it in, no space. Okay. So this is going to be our answer for this problem. This is going to be 3,5 diethyl, 3,8 dimethyl nonane. All right. So hopefully you guys are kind of understanding how to name these alkanes with substituents. And so once again, please try to go from the name to the skeletal structure or the expanded structure or the condensed structure, just to give you guys some practice. Okay. So, and you guys can do this for every single one. What does the expanded structure looks like? what does the skeletal structure look like? And what about the condensed structure? Okay. And so I think this example is pretty big, right? For the expanded skeletal. Well, this what you guys see here is the skeletal structure. So everything, so all the carbons and hydrogens that are being ignored, that's your skeletal structure. Okay. So that should be easy to draw. So this is going to be our last example for this video. Let's go ahead and quickly go through it. So the first step is figure out the longest carbon chain. 1, 2, 3, 4, 5. Okay. I have a branching point. 1, 2, 3, 4, 5, 6. So it looks like 6 right now might be my highest value. So I have another branching point. 1, 2, 3, 4, 5. Okay. Now there's also another one where it's 1, 2, 3, 4, 5, 6. So in this scenario, there's 2 paths that will give you 6 carbons. And so therefore there's going to be 2 correct answers. It just really depends on what you consider as your parent chain. Okay. And so I'll go ahead and do this path first. And then we'll go through the other one. What would the name be for the other path? Okay. So let's go ahead and number it. 1, 2, 3, 4, 5, and 6. Okay. Actually, let me move that 5 over. Okay. So here, if I'm going from left to right, let's see here. Looks like I have just one. Well, I have 2 substituents. So I have this as a substituent, that as a substituent. And so since I have both of them as a substituent and they're both on 3, I'm just going to put 3 plus 3, which is 6. Now I'm going to choose the green. I'm going to go the opposite path. So 1, 2, 3, 4, 5, 6. So if I go from right to left, if you will, then it looks like on carbon 4, I'll have those 2 substituents. So I'll have 4 plus 4. That's going to give me 8. And so it looks like the green lost again. The green is always losing in these examples. I have no idea why. And so this is going to give me the higher, that's going to give me a higher number. So I definitely want to choose the numbering system that's going to give me a lower value. And so if I were to name the substituents, I would have an ethyl. Okay. And I have 1, 2 carbons. And it's on the 3rd position of the 3rd carbon of the parent chain. And so here, this is also going to be another ethyl. And once again, it's going to be on that same, so if you guys kind of trace that bond back, notice it's on carbon 3. If I trace this bond back, that's on carbon 3. That's going to be 3 ethyl once again. Okay. And now that I've named all of my substituents, I'm going to go ahead and put everything together. Since I have 2 of the same ethyls, I'm just going to go ahead and write 3, 3 dash diethyl. And then I have hexane as my parent chain. And I'm done. Okay. And so I'm going to go ahead and copy this structure. And I'm going to go ahead and paste it. And this time we're going to look at a different numbering system. Oops. Oh man, that's hard to erase. I'll just redo it, whatever. Okay. Oops. All right. So earlier I mentioned that there's a different way to number this specific compound, and if you go from bottom to the top or top to the bottom, so this will also give me 6. And so sometimes you guys will get the same answer, sometimes you guys won't get the same answer. We can just go ahead and check to see if we're going to get the same answer that we did in this, when we did it the first time around. And so, so we still have 6, so this is still hexane. That's the parent chain. And if I number from bottom to the top, I have 1, 2, 3, 4, 5, 6. And if I number from the top to the bottom, I have 1, 2, 3, 4, 5, 6. And so 3 is less than 4. And so I'm going to go ahead and erase all of this because that is a lower value. I'm sorry, the one that I just erased would give me higher values. 3 is a lower value than 4. All right, so we're going to go ahead and highlight the substituent. And we're going to see if we get the same answer or a different answer. It just really depends on the problem. I think we're going to get the same answer because this compound is symmetrical. And so here in this case, notice that they're both on the 3rd carbon, right? So these are attached to the 3rd carbon. So I'll just go ahead and say 3-ethyl and 3-ethyl. And so since I have 2 ethyls, I'm going to combine them together. 3, 3 diethyl. And my parent name is going to be hexane. And so it looks like for this example, because it's symmetrical, both paths will give you the same answer. Both numbering systems, sorry, or what you guys perceive as the longest carbon chain will give us the same answer. And so for that previous example, for the isopropyl one, because this compound is not symmetrical, there are 2 different ways of numbering the longest carbon chain. There are 2 different answers, but they're both equivalent, right? Okay. All right, so I hope this clarifies the way to name these alkanes with substituents. In the next video, we'll go ahead and take it a step further, and we're going to learn how to name these alkanes with halo groups as our substituents. All right, see you in the next video.